Hello, I just wanted to do a small presentation on the project I did with Jess Levy um, and Manny Singh uh, regarding the research area and the removal of bittersweet there. The aim of the project was to use dendrochronology to assess tree health following the removal of Oriental bittersweet. So Oriental bittersweet came to this country in the late 1800s. People wanted to have it as a garden plant because uh, it was pretty. It it was attractive to look at. It has pretty berries. It provides good coverage and it's hardy and it's opportunistic. So it grows quickly and fills in spots and um, it was noted in the 1970s that it was invasive and that people should limit planting it. And excuse me, now it's located in 33 states and has known to take over tree stands and change the morphology of the forest from a temperate forest to an invasive thicket. It has a negative impact on forest communities because it girdles the trees, grow and the linnaeus grow up the trees and the vines dominate the canopy. Um, they have the ability to change the composition of the forest because the weight of the vines compromises the trees there and makes them more susceptible to storms and wind and it takes them down. It can also, the weight can break branches and prevent the tree from optimizing uh, photosynthesis. Um, so, so this project began back in 2013 when when a group of students managed the bittersweet at the research site. The original cohort of trees was 15, and with that they um, removed the bittersweet and collected data on the trees, noting the amount of bittersweet coverage and assess the health of the trees visually. Um, so only of the 15 trees of the original cohort, only 12 samples are surviving. Um, and the core samples were taken to analyze the growth since the removal of the bittersweet and before the bittersweet removal. So this is just taking core samples of a tree at the forest study research site. Um, she's using the tree borer and extracting the core from the tree. And this is in the lab where we dried and mounted the samples and aged them and then analyzed them using the software to measure the space between the tree rings to give us an idea of how the tree's health has improved or declined following the removal of the bittersweet. We had hypothesized that following the removal of bittersweet, the trees would be in better health, and this would show because there would be more space between each year's net gross primary production. And to our dismay, there was actually at the results actually showed the opposite. We took the 10 years prior to the bittersweet removal and averaged the ring growth, and then took the 7 years post removal and averaged the tree ring growth, and um, the tree ring growth was significantly lower in the years following the bittersweet removal. Um, this could be for a few reasons, especially because not enough time has passed for the trees to fully recover following the bittersweet removal. Trees are long lived, and like to grow branches and leaves to be able to fully have the full potential for um, photosynthesis and putting on biomass takes time. Um, Also, there were our cohort was of 15 trees. They were all different species. Um, and there's just not enough trees to really gather strong conclusions whether or not the health of the trees is improving following the removal of the bittersweet. Um, yeah, I think that girdling does damage the trees beyond repair. It can cause snags and it can take limbs off, which limits the tree's ability to do photosynthesis and put on biomass. So I really think that's more than the girdling. Um, and some trees are doing better. And this could be maybe a tree near them was taken down from the bittersweet, so they have more access to sunlight and now that the bittersweet's removed, they can grow better. After doing my forest study project about the red maples, I really think that uh, a tree when a tree can do photosynthesis, it can put on more biomass, and what the bittersweet's doing is limiting the tree's ability to do the photosynthesis by either covering the canopy or breaking off branches where it's getting the energy, where it's being able to do this. So, in conclusion, more time needs to pass, and this should be done again to assess how the trees are doing in the future. But this is a nice place to start. All right, thanks. Bye.